What if a drug that you've definitely heard of, one designed for diabetes and obesity, had a secret, totally life-changing side effect? Yeah, we're talking about those blockbuster drugs like Ozempic and Wegovy, and a story that science is really just starting to piece together.
It all starts with these incredible personal stories. Imagine this, a man who's been battling addiction for years starts taking a weight loss drug called semaglutide. And then, out of the blue, he emails a neuroscientist to tell her that for the very first time in his adult life, those powerful cravings that had run his life, they were just gone.
You see, this one powerful story blows the doors wide open on a massive question that researchers are now scrambling to answer. Is it possible that in the hunt for a weight loss solution, they accidentally stumbled upon a breakthrough for one of the toughest medical challenges we face?
To figure that out, we have to understand that this isn't just one guy's story. Not at all. It's a pattern, this really unexpected side effect that's popping up all over the place, forcing scientists to ask, wait, what else can these drugs do?
All across the world, people taking these GLP-1 drugs are reporting the same bizarre thing. That urge to have a glass of wine after a long day, it just kind of faded. The intense need for a cigarette, it vanished. It seems like these drugs aren't just quieting the food noise in people's heads. They might be turning down the volume on all sorts of cravings.
So, what is actually going on here, right? How can a drug that was made to manage blood sugar reach deep into the brain and rewire something as powerful and fundamental as addiction? Well, the answer seems to lie in the brain's reward system.
Okay, so your brain has this core wiring. Let's call it the reward system. It's designed to make you repeat behaviors that are good for survival, like eating or socializing. It gives you a little hit of pleasure as a thumbs up. The problem is, addictive substances totally hijack this exact same system. And what's so fascinating is how this process works. An addictive substance comes in and triggers a flood of this chemical called dopamine. That dopamine feels really good, and it basically trains your brain to want that substance again and again and again. It creates this incredibly powerful reinforcing loop. And here's the leading theory of what's happening. These GLP-1 drugs seem to get in the way of that dopamine loop. They don't block the reward completely, but they appear to just dampen the signal. The experience becomes less intense, less urgent. That dopamine hit feels more like a gentle tap. Now, this might feel like it all came out of nowhere, but scientists have actually been following a trail of breadcrumbs on this for over a decade. Think about this. As far back as the early 2010s, researchers in Sweden noticed these drugs were curbing cravings in rats that were hooked on alcohol and nicotine. But for the most part, the findings were ignored. Then, in 2015, the first real human link popped up. But it took a huge magazine article in 2023 for the rest of the world to really sit up and pay attention. Part of the reason for all the early skepticism really comes down to the drugs themselves. The first-generation GLP-1 drugs were just weaker, less potent, so the trials using them for addiction were, well, kind of underwhelming. But these new drugs, like semaglutide, are way more powerful and they last a lot longer in the body. And that's why there's so much excitement for the studies happening right now. But even with those weaker, older drugs, there were these flashes of potential. One study found that liraglutide, an older drug, still managed to reduce opioid cravings in people by an amazing 40%. That's a huge sign that the researchers were really onto something. And that brings us to today. The research is in full swing. We're talking more than a dozen major clinical trials underway, testing semaglutide against some of the most tenacious addictions we face, from alcohol and nicotine all the way to opioids and cocaine.